Welcome to another tutorial on Beckhoff automation products from ControlX. In today's tutorial, we'll be exploring some of Beckhoff Automation's product offerings. Beckhoff has been implementing open automation systems based on PC control technology for over 40 years. Their product range covers industrial PCs, IO fieldbus components, drive technology, automation software, machine vision, and much more. Today, we'll take a look at their EtherCAT DIN mounted digital and analog IO portfolio. We will explore the various product options available for these terminals, as well as product nomenclature and website resources available to select the right component for your application. So let's get started. Beckhoff offers many products for use in industrial automation and control systems. Their products are used in a wide variety of different applications, ranging from CNC controlled machine tools and wind turbines to intelligent building automation. Today, we'll be covering just one segment of their products. IO modules allow the automation software to interact with the physical world. They are responsible for bringing real world feedback like push button presses, limit switch triggers, temperature measurements, etc., into the PLC. They also allow PLC logic to control external devices like lights, buzzers, relays, valves, heaters, and many more devices. Beckhoff IO modules come in various flavors. In today's tutorial, our focus will be on the IP20 DIN mounted family of IO terminals. Specifically, we'll be looking at the digital and analog input and output terminals. The IP20 DIN mounted terminals are quite compact for their functionality, measuring about 100 tall, 12 wide, and 68 deep. Let's look at some of the housing data for the terminals. This information can be found from the relevant product page on Beckhoff's website. For example, this particular product is made out of polycarbonate material. It installs on a 35 DIN rail with a locking mechanism, which can be released by pulling the orange tab on the terminal. This section shows the information related to wiring, like expected wire gauge and recommended stripping length. Information is also provided for both solid and stranded wires, as well as wire with ferrules. The maximum load current is also specified here. The product name consists of two letters followed by four numbers. For example, EL2008 is an 8-channel digital output terminal. Let's break down the product naming to see how we can figure out the terminal information from the name. The first letter specifies the bus type. E implies E-bus and K implies K-bus terminal. All EtherCAT module names starts with E. The next letter specifies the wiring attachment or connection style. Cage clamp is the most common type. Next, let's look at the first number, which specifies the module type, whether it's digital, analog, input or output, measurement type, etc. All possible types are listed on the screen. The last number specifies the number of channels. Possible channel configurations are 1, 2, 4, 8, and 16. The number 9 is used for 16-channel terminals. The I/O terminals are mounted on 35 DIN rails, typically inside enclosures or cabinets. The terminals can be mounted to the right side of any embedded IPC, like the CX5000 series shown here. Alternatively, the terminals can also be used with an EtherCAT coupler like the EK1100 shown here. The EtherCAT couplers help extend the EtherCAT network and is considered a head station with which the terminal segment starts. Another connectivity option is a junction terminal like the EK1121, which can be placed at any position between the EtherCAT terminals and allow EtherCAT star topologies. Physically, the terminals are designed to be installed in a control cabinet or enclosure on a standard 35 mounting DIN rail by applying slight pressure until they click as shown. To install, first attach the IPC or field bus coupler to the mounting rail. The bus terminal can now be attached to the right side of the coupler or IPC by joining the components with tongue and groove and pushing the terminals against the mounting rail until the lock clicks onto the rail. If the terminals are clipped into the mounting rail first and then pushed together without tongue and groove, the connection will not be operational. When correctly assembled, no significant gap should be visible between the housings. To uninstall the terminal from the DIN rail, pull the terminal by its orange colored lugs approximately 1 centimeter away from the mounting rail. In doing so, for this terminal, the mounting rail lock is released automatically, and you can now pull the terminal out of the bus terminal block easily without excessive force. The optimum installation position requires the mounting rail to be installed horizontally and the connection surfaces of the terminals to face forward. The terminals are ventilated from below, which enables optimum cooling of the electronics through convection. From below is relative to the acceleration of gravity. Compliance with the distances shown here is strongly recommended for the optimal heat dissipation from the terminals. Finding product information online is fairly straightforward. Head on to Beckhoff's website as shown. Go to the product page and navigate to the EtherCAT terminal page from there. Let's explore the digital input terminal page first. Here we can use the filter options to find the right kind of digital input terminal for our applications. Let's go over some of the common options. We can filter by the number of channels. 2, 4, 8, or 16 channels are available. There are also combi terminals with both digital input and output channels on the same terminal. We can select input voltage. A wide range of input voltages are available from 5, 12, 24, 48, and up to 120 and 230 volts. The digital input terminals come with various filter options, from 0.05 microseconds up to 30 milliseconds. The filter time refers to the time over which an external signal with rated voltage or zero signal level must be present at the terminal input for it to be registered as a high or low by the input circuit. Various input output specifications are available, like positive switching, ground switching, OSSD signal, etc. The XFC filter allows selection of options for distributed clocks, oversampling, time-stamped inputs, and such. Let's look at one commonly used digital input terminal called the EL1809. As the part number suggests, this is a 16-channel input terminal rated for use with 24 volt logic level. The states of the digital inputs are indicated by means of 16 LEDs in the top part of the terminal. The position of the LED corresponds to the position of the related channel, with channels 1 to 8 on the left side and 9 to 16 on the right side. The power contacts are connected through the preceding terminal to its left by means of these blades. Input signals can be connected to the respective channels using one wire each. When the input signal is switched on by means of a 24 volt logic level, it is interpreted as a high or true in the PLC, and a 0 volt or floating input is interpreted as a low or false in the PLC. The product page lists all the relevant technical data as well as downloadable commissioning instructions for the terminal. Let's look at some of the specs for the EL1809. One wire connectivity means all input signals are referenced to the 0 volt feeding the power contacts of the terminal. So external signals can be wired to the terminal using one wire only. This shows the number of input channels. Normal operating voltage is 24 volts. A low signal is interpreted if the input voltage is between -3 and 5 volt as per IEC 61131-2 standard. A high signal is interpreted if the input voltage is between 11 and 30 volts. This terminal has a 3 millisecond input filter. This means that the input signal must hold its value for at least this amount of time for it to be registered as a high or a low. Other part numbers are available with different input filters. The terminal's power consumption is listed as typically 100 milliamp. Care must be taken to ensure that sufficient E-bus current is available if installing multiple terminals to a coupler. For example, the EK1100 coupler can supply 2 amps to the E-bus. Current supply can be replenished by installing an EL9400 terminal. The electrical isolation between the E-bus and field input is good up to 500 volts. Relevant approvals and markings are also shown for the terminal. Next, let's explore the digital output terminals. Their part number starts with EL2, and the next three numbers specify the various options available. Let's review some common options. Various output channel options are available, including combi options with digital inputs and outputs on the same terminal. Various output channel options are available besides the standard digital on-off logic level signal. For applications requiring PWM switching, terminals like the EL2502 is available, which is a two-channel PWM output with a max output current of 0.5 amp per channel. This can generate PWM output with frequency range from 1 Hz to 125 kHz. Terminals with various relay output options are also available, like the EL2634, for example, which is a 4-channel output terminal. The relay contacts can be used for up to 250 volt AC or 30 volt DC voltages. The EL2634 features potential-free contacts and is good for connection of both ohmic and inductive loads. Various output voltage ranges are available to choose from, ranging from 3.3 volts up to 230 volts. Similarly, various output current options are also available to choose from, ranging from 20 milliamps up to 10 amps. Let's look at one commonly used digital output terminal called the EL2819. As the part number suggests, this is a 16-channel output terminal, rated for use with 24 volt logic level with max output current of 0.5 amp per channel. The outputs are short circuit proof. A special feature of this terminal is that it offers diagnostic info such as short circuit and open circuit detection, overcurrent, over temperature, voltage loss, and under voltage detection. This information can be accessed via its process data. Next, let's explore analog input terminals. Their part numbers start with EL3, and the next three numbers specify the various options available. Let's review some common options. Various output channel options are available, including combi options with analog input and outputs on the same terminal. Various input signal types are available besides the normal voltage and current analog inputs, including acceleration, pressure, temperature, resistance, and many others. These are the available value ranges option for analog inputs. As you can see, all common input ranges used in the industry are available, with the standard 0 to 10 volt or plus minus 10 volt to 4 to 20 milliamp. In addition, potentiometer inputs, resistance input, and many other options are available to choose from. The analog input signal is digitized and transmitted electrically isolated to the higher level automation device. The resolution of this digitized value depends on the signal resolution of the terminal chosen. Available options are from 12 bits up to 24 bits. The bit for the algebraic sign is included. That means, for example, a 16-bit terminal has 1 bit for sign and 15-bit effective resolution. This indicates the relative measuring error of the analog input and is related to the full scale measurement value. Various reference options are available to choose from. Most common signal types are either single ended or differentials. Here is an example of the new upcoming EL3078 analog input terminal. This is the 8 channel version of the multifunction analog input terminal. It can be configured in TwinCat settings to work with voltage signals like 0 to 10 volts, minus 10 to plus 10 volts, or current signals like 4 to 20 milliamps, minus 20 to plus 20, or 0 to plus 20 milliamp. The analog input signal is digitized with a resolution of 16-bit, including sign. In terms of signal reference, this is a single-ender terminal, which means that one connection point of each channel is already connected in the terminal to plus 24 volt or ground, and no longer needs to be wired separately. This terminal has a default conversion rate of approximately 500 microseconds, which gives it a sampling rate of 2 kilosamples per second. Finally, let's explore the analog output terminal options. Their part number starts with EL4, and the next three numbers specify the various options available. Let's review some common options. Like the other terminals, the analog output terminal also comes in 1, 2, 4, or 8 channel configurations. Combi option with analog input and outputs on the same terminal is also available. The analog output terminal comes with either current or voltage output options. Comes with standard output value ranges like 0 to 10 volts, plus minus 10 volts, 0 to 20 milliamps, and 4 to 20 milliamps. In addition, other output voltage ranges are also available as shown. Available output signal resolution options are 12-bit and 16-bit. These are available options for measurement error and conversion time options for analog output terminals. High sampling rates up to 50 kilosamples are available on some models, with oversampling like the EL4712 and EL4732. These are both two-channel output terminals with oversampling capability. The EL4712 is a current output terminal, while the EL4732 is a voltage output terminal. I hope this introductory tutorial on some of the commonly used Beckhoff IO terminals was helpful. In future tutorials, we'll cover other terminals like the safety IO, position measurement, communication, and many others. Coming up in the next tutorial, now that we have a good idea about some of the analog and digital IO terminals, we will learn how to set them up in a PLC project. We will create a new PLC project and add some IO terminals. Then we will configure the IO terminals and link them to the PLC project. Finally, we'll exchange data between the PLC project and the configured IO terminals. That's all for today's video. What type of terminals have you used in your projects? Are there any specific type of terminals you want to see a tutorial on? Do let me know in the comments below. And if you found this video helpful, then please consider subscribing so you don't miss out future tutorials. As always, thank you for watching and keep innovating.